Welcome, class, to lecture number 6, covering pressurization systems on the CRJ 700. Let's go ahead and get started. And here I am. I'm your instructor, Tom Mahoney, once again. And here we go. Pressurization uses pneumatic air from the air conditioning system. It all starts at the engines with bleed air. So we've covered pneumatics, and now we've covered air conditioning. So we put those two systems together, and it supplies the aircraft with pressurization, at least for commercial aircraft. Again, the basic principles: oxygen in the air is about 21% of the total volume at all flight altitudes. To maintain oxygen through the lungs requires atmospheric pressure. Air enters the cabin from the air conditioning system. When the cabin doors and windows are closed, the cabin becomes a pressure vessel. The pressure is controlled by an outflow valve, normally towards the rear of the pressure vessel. Easy for you to say. Normally, for most commercial aircraft, the maximum cabin altitude should not exceed 8,000, and the maximum pressure difference in the cabin should not exceed, between the cabin and the external surrounding air, should not exceed 8.6, so that we can maintain structural integrity of the aircraft. The pressure vessel is pressurized by the air conditioning system. Normally in flight, we use bleed air from the main engines. However, we can use bleed air from the APU in certain cases when we are below 25,000 feet, as far as the CRJ 700 is concerned. So this demonstrates what the pressure vessel might look like on the CRJ 700. It's a single vessel, and some aircraft use more. So pressure controllers are the computers on board that modulate and control the pressurization in the cabin and flight deck. There are two automatic pressure controllers. There's one manual pressure controller. So we actually have 3 pressure controllers on the aircraft, 2 automatic and 1 manual. The controllers manage and regulate the outflow valve on the aft pressure bulkhead when the aircraft is in flight. The outflow valve is the primary method of pressure control. 2 safety valves provide protection against overpressurization and negative pressure. And additionally, a ground valve dumps air when the aircraft is on the ground. So that's what we have here. We have all those particular features involved here. We'll just take a look at them. Here's your number 1 auto pressure controller. There's number 2. When those 2 fail, then we switch over to the manual mode, where we control pressurization with a manual altitude switch. We have some motors here. This is a manual motor. These 2 are the automatic motors. And then, of course, we have an actuator here that opens and closes the outflow valve towards the aft pressure bulkhead. And we have our ground dump valve right here. So that's it. That's where that's all the parts, basically, of the pressurization system for the CRJ 700. At least that's the big picture. Let's continue. The control panel and monitoring panel consist of these items. The pressure control panel is located on the upper right-hand corner of the overhead panel. That would be this guy right up here. If you were looking at the cockpit, you'd see a little bitty panel up there, and that controls the pressurization. This is what it looks like when we expand the view. So this is that in that area, and that's what controls the pressurization. That's it. That's all there is to it as far as the panels go. The pressure control switch selects which auto controller will be used, or can select the system to manual control if required. Where's that at? That's this switch right here on the panel. Says pressure controller, abbreviated. And the right screen down here provides the operator with pressurization information when the ICAS panel is selected to status. So there's the information we're getting off of that panel when we have selected this button from this panel. Okay, hope that all makes sense. I know it's pretty quick, but that's the way it works. Let's move on. So as far as the auto controllers go, you have two of them. One is going to be the active controller and one is going to be the standby controller. When operating in automatic mode, only one controller will be active at a time while the other one remains in standby. If the active controller fails, the system will automatically switch to standby. If the system does not automatically switch, it can be forced to switch by pressing the pressure control switch twice. And we already looked at that on the pressure control panel on the upper overhead panel, upper right-hand corner. If both automatic controllers happen to fail, then we can select the pressure controller switch one more time, and it will take us to the manual mode. So in this scenario, we have a green auto pressure controller actually operating, and it provides instructions and power to the number one motor. This motor actuates the actuator, makes that actuator move. So we have a rod or some sort of device, mechanical device, that moves back and forth and opens and closes the outflow valve. If this active controller were to fail, then the second automated controller jumps in place, replaces it, becomes the active, then it ends up powering all the way across to its motor, which then, of course, does the same thing. But let's say both controllers fail or both motors fail. At that point in time, we are now reliant upon ourselves to operate the manual altitude switch, which now we would be running this motor, the manual motor, and it would also then move the actuator device to open and close the outflow valve. But of course, we would have to be doing that manually, kind of like what we used to do on the old 7.2 as a flight engineer. That's what makes this automated stuff so nice, because it takes a person out of the flight deck to where we only need actually two pilots, and the aircraft is much more manageable using automation. So let's talk about manual pressurization. When using manual pressurization, verify the pressure control switch says manual on it, and press manual appears on the ICAS synoptic page. The manual rate knob can be set to the desired rate, and the cabin pressure can be controlled at that rate by pressing the manual altitude selector switch to the up or down position. So what are we really talking about here? Let's zoom in just a little bit here and get a closer look. Okay, now that I've gotten back to the correct page, let's take a look again at the actual panels involved. We have our pressurization panel right here. And then we have the ICAS here that is giving us information. Now, to make sure when we are on manual that we have the pressure control switch right here selected to where it says manual. And then let's make sure that we have pressurization manual indicated on the ICAS. Now we know we're in manual pressurization. At that point in time, we would select our rate knob. This is the manual rate knob right down here, to either decrease the rate that we want to change the cabin pressure or increase the rate that we want to change the cabin pressure. Once we've selected the rate, then we go up here and we can push this switch. That's a toggle switch. We can push it up or down to change the cabin pressurization. What that switch is actually doing is sending a signal to the manual motor to operate in one direction or the other. So there's our manual switch right here that we're talking about. Comes down here, comes this way, sends a signal to the manual motor, which of course, when we operate it in one direction or the other, it moves the actuator rod, which is mechanically attached to the outflow valve, and the outflow valve will move however far we want it to, and it will open it at a given rate so that we can change the pressure either 200 feet per minute or 500 feet per minute, whatever feels comfortable, whatever we're actually climbing the aircraft itself at, we can make those determinations as the pilot, and we can manually control the pressurization on the aircraft. So it takes several things. Again, make sure that the switch is in manual, that we have pressure manual indicated on the ICAS, select our rate to the appropriate rate that we want, and then we can toggle the switch up or down to decrease or increase the cabin pressure. Simple as that. So let's take a look at the outflow valve. The outflow valve is the primary valve that controls the rate that the cabin air pressure is decreased or increased. So the outflow valve is going to open or close depending on what is commanded. So there's the outflow valve. In this case, we are in automatic mode because the diagram here shows motor number 1 in green, motor number 2 is in standby, and manual is not in the picture yet unless we select manual ourselves. So right now we're using auto pressurization. The outflow valve is the primary valve that controls the rate that the cabin is pressurized. Is decreased or increased, it is directly controlled by the actuator that is connected to the pressure controller, either number 1 or number 2, or the manual pressure controller motor. So it works that way because the motors are connected, all three, to the actuator. Now, this is a placard that would be in pretty much every aircraft that you'll be flying. It's a backup placard. When we are operating the pressurization in manual, we would take a look at this and see what we need to be getting this aircraft set to when we're at different altitudes. So for example, let's say the aircraft is at 20,000 feet. We would want to adjust the manual pressurization to read a cabin pressure altitude of 1,500 feet. Of course, if we are at 41,000 feet, the aircraft that is, then we want to set the cabin pressure to around 8,000 feet. That's about the maximum altitude we can drive the cabin up to, or I should say, actually drive the cabin altitude down to in relationship to the aircraft being at 41,000 feet. Same thing goes here with 20,000 feet, we would drive the pressurization in the cabin down to 1,500 feet. So as I said, this is a placard you'd be referring to if you were operating the aircraft in manual. So let's talk about the safety valves. There are safety valves. We talked about this in a previous video, but the positive safety valve, safety differential valve, allows the cabin air to escape when the interior to exterior pressure exceeds 8.6 plus or minus a tenth of a psi. So there's your safety valve. And apparently on this aircraft, it's showing us that it has two. One must be a backup to the other, just to make sure we do not over pressurize the interior cabin. The negative safety differential valve prevents the cabin from exceeding a negative pressure of 1/2 of a psi, so that we don't actually crush the cabin. When might that happen? Let's say we landed and for some reason we have more pressure outside of the aircraft than we do inside. Not sure exactly when this might happen, but we would have this negative pressure relief valve that allows air to enter the cabin as necessary to equalize the pressure inside and out. Now we've got the ground valve that is pretty much on most aircraft that I know. The ground valve is a valve that is normally open on the ground when the passenger or service doors are open, and that's how it works on this aircraft. The ground valve automatically closes at the start of pressurization. So if we close all the doors and we're taxiing out and we're getting ready to take off, the ground valve would begin to close to make sure that we were able to hold air pressure inside the cabin as we prepared for takeoff. As we land the airplane, the ground valve is going to open to make sure that the aircraft is fully depressurized by the time we get to the gate. Nothing's more embarrassing. I remember on the DC-9 where we operated this somewhat manually, we had to make sure that the ground valve was open. We'd taxi up to the gate and shut the engines down, and right after we did that, the main cabin door would open up and you'd hear this big swishing sound as the door opened. And what it would remind you of is that you forgot to open the ground valve before you got to the gate and the airplane was still pressurized. Of course, the gate agent and the flight attendant would give you a dirty look like, don't you know what you're doing up there? These doors are hard to open if the aircraft is still pressurized. So that's kind of what the ground valve does. Make sure the aircraft is fully depressurized so you can get the doors open. Now we have emergency depressurization. It is a guarded switch on the cabin pressure controller. That guarded switch is right here. If you flip that guard up, you could push that switch. Now what that's going to do is it's going to dump pressure out of a pressurized aircraft. When would this switch be effective? Well, if you are above 15,000 feet with the aircraft, you can press that switch and the cabin will depressurize to no higher than a cabin pressure of 14,500 plus or minus 500 feet. So why would we use a switch like this? Well, let's say we had smoke or fumes on the flight deck and we needed to vacate that to get it out of our face so we could actually continue to operate the aircraft without a chance of becoming asphyxiated. So we'd push that switch. Of course, that would take air out of the cabin, hopefully discharge it overboard of the aircraft, and then we could figure out what the situation was and handle it and make things much more convenient. However, in the meantime, it's going to depressurize the airplane up to a cabin altitude pressure of 14,500, which is going to give us some other issues. And that's going to be a loss of cabin pressure. Now let's think about this for a second. When the cabin altitude pressure exceeds 10,000 feet, we're going to get an alert on the flight deck, and it's going to say something, and we're going to see cabin altitude, and we're going to get an oral warning that is heard. So now we know that we've gone above a 10,000 foot cabin altitude. For example, if we forgot to pressurize the aircraft at all before we took off and we fly up to a pressure altitude of 10,000 feet, that would be the same as having an unpressurized aircraft, and we would get these alerts. If we were at, say, 30,000 feet and we began to lose the cabin pressurization, by the time the cabin pressurization reached 10,000 feet, then we would get another cabin alert, altitude alert, and again, an oral warning. So in the case of depressurizing the aircraft intentionally for an emergency depressurization, we're going to drop the altitude, cabin altitude, we're going to bring it up to 14,500. And in this case, if the cabin altitude pressure change reaches 14,000 feet, the passenger oxygen system will open, the overhead compartments above the passenger seats, and the passenger O2 mask will drop. So that's not what we really want, but that's what's going to happen. In that case, we're going to want the passengers to go ahead and pull down the mask, put the mask on for oxygen. However, there's something that you need to understand if you've been on a commercial airliner. You remember the flight attendants always giving you their briefing, and they always talk about in the unlikely event that the aircraft becomes unpressurized, mask will drop from the ceiling and you will reach up and pull those masks down, place the mask over your nose and face, and continue to breathe normally. What they kind of slide over is when they say pull the mask down and put it on your face. What they're really telling you is that the mask is hooked to a little cable right here. And this mask is hooked to another little cable right here. Doesn't matter which mask you pull down, but what you're really doing is you're pulling on this cable here. Now, when you pull on that cable, there's a switch up inside the compartment here attached to this oxygen canister right up in here. And when you pull on that cable, it pulls that switch to the open position. And then the oxygen canister begins to chemically create oxygen, which is what comes down through the tube to the oxygen mask. If you do not pull the oxygen mask down, thus pulling on that cable, there will be no flow of oxygen. A lot of passengers completely miss that because of the way the announcement is made, but that's just something I picked up over the years. I've always scratched my head. Why don't they make that more obvious to the passenger that you're actually pulling down on a cable here to get the oxygen mask, the oxygen to flow to the mask. So just my little pet peeve about how they make their announcements back there. Let's talk about the cabin pressure schedule. So let me just take you back a few slides. I think we can do it right here. You'll notice that on this slide, we have a knob right up in here. This is the landing elevation knob. So you would dial that until you saw the landing elevation appear on your ICAS right down here. Landing elevation would simply mean what is the elevation of the airport that you're going to be landing at. You would figure that out either by charts or you could go into the database of the FMS. Whichever way you want to figure it out, you need to know what the landing elevation of the airport is. You turn this knob up here and it will adjust this landing elevation to the appropriate airport elevation. Then you've set up the aircraft to or the FMS to know how it's supposed to manage the pressurization. So with that understood, let's go back and talk about cabin pressure schedule. Because the aircraft already knows the altitude it is when it's taking off, What it needs to know is the altitude of the airport that it's going to be landing at. That's the first thing you need to understand. So you've told it that what that's going to be when you set up your pressurization controller, when you began to configure the switches before takeoff. So when the overhead pressure panel is set up during pre-flight, the pilots enter the landing airport elevation. This sets up a schedule of pressurization events in the proper order. One of eight pressurization modes will begin to function depending on the phase of flight. So, for example, if you are in the ground mode right here, that corresponds to that position of the aircraft. The outflow valve and the ground valve are going to be fully opened. When you enter the pre-pressurization mode, the next mode over, as the thrust levers are positioned for takeoff, the outflow valve begins to close to start the pressurization process, and it will pressurize the aircraft at approximately a 300 foot per minute rate. Let's move on to the climb. In the climb mode, the cabin pressure is set to climb at 300 to 350 feet a minute. And then you can look at the rest of the modes when you get to the AeroSim, and it will go through most of them, I believe, and describe what they are. If you are in the flight mode, I've always thought this one was pretty handy. If you're in the flight abort mode, what happens is after takeoff, if the aircraft remains at 6,000 feet or lower for at least 10 minutes, the pressurization system, the computer, assumes a return to the departure airport is going to be made. In that case, it says, no, we're not going to our destination airport. Something's occurred with the aircraft, or maybe we have some sort of passenger issue, or we've lost an engine. But in any case, we need to return to our departure airport. And in that case, the depressurization schedule uses the departure airport to calculate a new depressurization rate. So it takes that elevation that it's started out at instead of the landing elevation and calculates through the computer systems, the pressure computers, that, hey, we need to recalculate our depressurization rate so we can have a gradual depressurization suitable for that airport elevation. So that's it for the pressurization module. Again, go to your AirSim module, look it over. There's more detail in it. I just want to give you the broad coverage. If there's any questions about it, of course, you can always call me. Otherwise, look at the AirSim module. Make sure, again, you sync up so that I know you've looked at it. That's part of your grade. That's part of the process. And then get over to Hangar Talk for pressurization. Ask that question that you were just burning to stump all your classmates on. So there you are. Until then, all I've got to say is this module is complete and I love my job. Glad to be here. Hope I can make it in.